All right, welcome to Newton's second law, part one. And in today's lesson, all we're going to focus on is horizontal motion problems. We'll focus on pulley problems and elevator problems next day. So in short, what is Newton's second law? Well, it's when an external non-zero net force acts on an object, the object accelerates in the direction of the net force. The magnitude of the acceleration is directly proportional to the magnitude of the net force and indirectly proportional to the mass of an object. So that's where we get this idea that the net forces is equal to the mass times the acceleration. And that's the formula that we're going to be working in now. This F net is equal to ma. We also need to understand the concept of inertial mass. Inertial mass is a mass measurement in kilograms, or SI units, and this is based on the ratio of a known net force on an object in relation to the acceleration of the object. So it's the same formula, just manipulated around, so it's already solved for m. And you could do the same sort of setup here, that you could find the acceleration if you know the net force and you know the mass. So there's three different representations of this equation that is just simply done by swapping it around as you solve for the same variables. Now, these are some good steps and understandings for while we're applying Newton's second law. So as with most of our motion problems, frictional forces are considered negligible and can be ignored unless we specifically have a frictional force, in which case then we incorporate it. With horizontal motion, the vertical forces, so the forces that are applying in the upwards and downwards or north and south directions, are balanced. So the F net is 0 and our acceleration is equal to 0. So there'll only be a net force in the horizontal direction. So it was like in the last few sections where we were always trying to break things down into component parts, that when we're looking at this object, this Fn is equal to the Fg. They're going to have the same magnitude. If you're given F net and one of the other variables, just use F net is equal to ma, our formula, and solve for a required variable, knowing that we have those three different representations. If you're given a number of horizontal forces, draw your free body diagram. And then you'll be able to resolve what all of our horizontal F nets are, and then we can use the formula to solve for it. So if we had a bunch of forces that said, Kate, we have one person pulling here, one person pulling here, and then we have the frictional force here, you need to figure out what is the actual net force of the horizontal direction, so your F net X, to be able to solve for your total F net for your mass and acceleration. We're going to use an example here, and I see that it's a teeny bit cut off. There's nothing really too much more up there. I'm just going to draw it down a little bit. It's just our little reference, like this, where up and forward are positive and backward and down is negative. This is an example from the Pearson Physics 12 textbook. On page 149, example 3.5, a lacrosse player exerts an average net horizontal force of 2.8 newtons forward on a 0.14 kilogram lacrosse ball while running it in the net of a stick. Calculate the average horizontal acceleration of the ball while in contact with the lacrosse net. So I have an F net because I am only given one force. I can assume that this is my net force. My mass is given to me, and it's in kilograms, so I don't need to convert that. And then I know I'm trying to find my acceleration because it's asking for the acceleration. We're going to use our equation. F net is equal to ma. And in traditional good physics, we like to try to isolate for a variable first. So we're going to set up our equation using one of our different representations, that acceleration is equal to our F net over m. So acceleration is equal to 2.8 newtons over 0.14 kilograms. And this is a good point to remember that newtons is kilogram meters per second squared. So these kilograms will cross out, and then you're just going to be left with your unit of acceleration. So then our acceleration is going to be to 2 sig figs of 20 meters per second squared. Or let me double check that. That seems like too good of a round number. And it is. That is exactly the round number of it. So this is 20 meters per second squared. The average horizontal acceleration of the ball is 20 meters per second squared. So it's comparatively easier than some of the stuff that we've been doing in terms of what formula we're using, that it's a quick little swap in between the three. If you have any questions, of course, ask. And then I wanted to get into another problem right away. This one's a unique problem because we have to decide what the system is. Before, the system was just the guy with the ball. Before, systems were just this box. So let's talk about what we're given. We have 2 athletes on a team. A and B are practicing to compete in a canoe race. That's the figure up there. Athlete A has a mass of 70 kilograms. B has a mass of 75 kilograms. So we have mass of person A, 70 kilograms, mass of person B, 75 kilograms, and the mass of the canoe is 20 kilograms. That's right here. Athlete A can exert an average force of 400 newtons forward. So then we say that the force of athlete A is 400 newtons. Force of B is 420. And then it says, during paddling, the magnitude of the water resistance on the canoe is 380. So that tells us that it's like a force of friction. You can also just call it FW, force of water. But both of these are forwards, so we should clarify that. I should actually just use the shorthand for that. 380. Backwards. And it wants to calculate the initial acceleration of the canoe. Let us start with a free body diagram. I know typically I'm a fan of drawing boxes, but I've been told I need to kind of switch over to circles. I'll try to do my best for both. So let's talk about this. We know because it is a horizontal motion problem, we still have these forces. We need to acknowledge that we have our normal force and we have our force of gravity, but they zero each other out, so we don't have to really consider them. We're going to have our reverse force here, your FW, or your FF, depending if you're doing your force of friction or not. Then you have 2 forces forward. You have F, I'm going to put FB on top because it's slightly longer. I'm going to start by saying that this is negative 380 newtons because we know it's in the reverse direction that it should be. So, if I want to find my F net in my horizontal direction, because we know that it's going to equal 0 in the vertical direction, because these guys are going to essentially equal each other, but the negative version of it. So our F net in the x direction is going to be FA plus FB plus FW, which gives us 400 newtons plus 420 newtons plus negative 380 newtons, which will give us a resounding 440 newtons. Okay, so now we're going to calculate our acceleration in the horizontal direction, which means that we're going to use our formula mass times acceleration. Now we have all of these, we have so many different masses that we need to have the mass of the total system. So mass total system is going to be 70 plus 75 plus 20 to give us a resounding 165 kilograms. And then we're going to solve for acceleration. So acceleration will equal 440 divided by 165, 2.7 meters per second square. So the initial acceleration is 2.7 meters per second squared. And of course, pause the video at any time to go over anything or to be able to write everything down. Now, this is all I wanted to go over today. You guys are doing this on your own, so I want you to make sure that your reading is done. Attempt your reading comprehension question. Question 1 on the numerical problems. And I want you to attempt, if you'd like, additional practice problems on page 149, 150, or the check and reflex numbers 5 to 7, and submit that additional work for clarification if you want. If you want to do well, do the additional stuff and send it in. Even though it's not for marks, it'll definitely help you guys and give you some more time to understand those topics that we're working on. I hope that was helpful for you guys. Have a good rest of your day.